Chapter 11 is looking at stoichiometry, and stoichiometry can be boiled down to looking at or talking about the math of chemistry. So the first thing we need to remember, and I did talk to you about this last chapter when we were talking about writing out a balanced chemical equation, the coefficients in that equation can have one of two meanings. They can either represent the number of atoms and or molecules that are involved in a chemical reaction, or they can represent the number of moles of atoms or molecules. Now, for our purposes, the second one actually makes a lot more sense because we can't pick up individual atoms or molecules and put them together, but we can take collections of atoms or molecules, in other words, moles of atoms or molecules, and react them together. So for our purpose, the mole is a more practical unit of measurement. So from a balanced chemical equation, it's possible to obtain something that's called mole ratios. And those relate either reactants to reactants, reactants to products, or products to products. Looking at the example that you've got, so I can say I have 2 moles of hydrogen peroxide reacting with 1 mole of oxygen, a comparison between reactants and products. Now, because I can make those statements, that actually means that I can produce a unitary rate. So a rate that I can use and invert to change units from one to another. So let's look at this particular example. We've got hydrazine, which is N2H4, and hydrogen peroxide, and they're actually used for producing rocket fuel. When they combine chemically, they produce nitrogen gas and water, as well as a large amount of energy. Now that's based on the following chemical equation. 1, if you're given a statement like that, you should be able to put it together and know that which of those chemicals are reactants and which of them are products. And like I said to you last day when we were talking about chemical reactions and types of chemical reactions, it's really important here that when you look at these things, your instinct has to be to balance it. Now, how you identify that you have a stoichiometry question is that you actually are asked about 2 different chemicals in the same question. So an example of this would be how many moles of hydrazine are needed to produce 12 moles of water. Notice in one part of the question I'm asked about hydrazine. In a later part I'm asked about water, and that's the indicator that I'm looking at stoichiometry. So, using the standard way of solving using unitary rates or factors, what we're going to do is we always start with the number we're given in the question. In this case, we're given 12 moles. And for stoichiometry, you have to identify the chemical that you're given in the question. So in this case, water. Now that's important because although we kind of glazed over it last time, when we look at stoichiometry, it's important to keep in mind that your units actually have 2 parts to it. It actually has the unit, so the mole or the gram or the second or the liter, and it also has the identity of the chemical you're talking about. And what we see is that we can only change one of those 2 parts of a unit at a time. So, anytime you're asked to change a unit, you know always you need to draw an X and a line. The unit that you're going from goes on the bottom, so I'm going to put moles of water on the bottom. And now I know that 1, I can only change one of those parts of the question, or one of those parts of the unit, and 2, I have to look at, well, what is the thing that it's asking me to calculate? Well, it's asking me to calculate moles of hydrazine. So that means I'm going to keep the mole part of the unit together, and now I'm going to change it to hydrazine, N2H4. Looking at our balanced chemical equation, what we see, let's flip back to the last screen for just a second, what we see is that we had 1 mole of hydrazine for every 4 moles of water, because there's an invisible 1 here, and there's a 4 in front of our water. So we had 1 mole of hydrazine for every 4 moles of water. Do I have the unit that it's asking me for in the question? Well, yes, so I put an equal sign. So this means now I take 12 and multiply by 1, then divide that by 4, and that gives me 3 moles of N2H4. when you're looking at your sig figs here, we assume that these mole ratios are perfect. Okay, so these mole to mole ratios, or mole ratios as we call them, do not count for sig figs. So I would like you to try this particular question on your own, and then we'll give the answer. So now if you've tried it on your own, again, we always start with a number that we're given in the question. In this case, 4.76 moles of H2O2. You have to keep both the unit and the identity of the chemical together. And it says how many moles of water are produced. So to change that unit, I'm going to draw an X and a line. The unit that I'm going from goes on the bottom, so the moles of H2O2 goes on the bottom. And the moles that I'm going to are going to go on the top. Notice here that the mole is the same, it's the identity of the chemical that's changing. So looking at our balanced chemical equation, I'll abbreviate this as a BCE, balanced chemical equation, we have two H2O2s react to produce 2 moles of water. Do we have the units that were asked for in the question? Well, yes. So I put that into my calculator and you get 4.76 moles of water. Some people can do this particular portion of stoichiometry in their head, and if you're one of them, then you're certainly capable of doing that, but I'm going to caution you against it because it's part of the pathway that I'm going to show you later on. So next day, like I said, you're going to do some practice. We'll come back to that practice later, but I want to move on one step further and introduce to you how we can do a multi-step pathway. Stoichiometry really involves measuring or calculating the amounts of reactants and or products in a chemical equation from a balanced chemical reaction. Usually, the amounts that we're asked to calculate are expressed in moles or grams, but certainly you could be asked to calculate things like liters of a gas or concentration of a solution. Now, the steps that are involved in solving for stoichiometric questions are the ones that you should already be familiar with from your mole, from the mole unit. So 1, we have to be able to balance an equation. 2, we have to be able to convert between mass and moles. Remember that the comparison for mass to moles is our molar mass. And that number comes off the periodic table. We also have to be able to go from moles to mass, so the opposite way around. That's again using your molar mass from the periodic table. And we want to be able to compare moles of one thing to moles of another. That's coming from our balanced chemical equation. Now, there's 3 kinds of questions that we can be asked to look for. You can be asked to calculate mass to moles, you can be asked to go from moles to mass, and you can be asked to compare between mass and mass. Let's start with going from moles to mass. That's our first introductory statement, although going mass to moles is really the same but in the opposite direction. So the moles that we are asked to calculate here can either be reactants or can be products, as can be the mass that you're asked to determine. Now, for example, we're going to look at the reaction that has water being produced when hydrogen reacts with sufficient oxygen. If the reactants aren't measured or mentioned in terms of quantity, like it says here for oxygen, then you can assume that there's enough for the reaction to go to completion. So, balanced chemical equation. 1. When we look at this, remember that hydrogen as an element on its own and oxygen an element on its own are both diatomics. That's important, otherwise your balanced chemical equation is going to be off. 2, we have to balance it in terms of numbers of atoms on both sides of the reaction. Now, I'm going to write this out a number of times, but certainly you can draw this information around yours. But I'm going to ask you to draw yourself a map. And some of you will be hesitant to do this, but until you become familiar with it, I'm going to ask you really to try this out. Around your chemical equation, I'm going to ask you to write moles underneath the appropriate chemical. So you were given in the question that there was 5 moles of hydrogen. So underneath the hydrogen gas in the reaction, I'm going to write 5. Any masses that you're given are going to go on the top. So in this question, we were asked to calculate the mass of water, so we have to put, I'm going to put a question mark over it. You could put a star, anything so that you know where you're trying to get to in the calculation. Now, once we have that done, we're going to set up a diagram for how to get from what we've given in the question and what we want to calculate. So, you can only go in straight lines, side to side and up and down. So in order to get up to the top for the water, I'm going to go first across the bottom, and then I'm going to go up. You cannot go on diagonals because mathematically that would be the same as changing both the unit and the identity of the chemical at the same time. The second thing that we need to do, and I'm going to liken this to actually talking about the mole, is that remember that when we talk about the mole is a furry little creature that's blind and it lives most of its life underground. So although you may be tempted to go up first and then across, there is a fence here across the top that doesn't let you go side to side at the top. You can only go side to side across the bottom. Now once you have those that set up, it actually will show you how to do the calculations and how to proceed. For example, it tells you that you have 2 arrows, so that means you have 2 steps in your calculation that you need to do. You always start at your number that you were given in the question. So I had 5.0 moles of hydrogen, and I'm asked to change the unit. I hit an arrow. Now that means I need to draw an X and a line. The unit you're going from, the end of the arrow, goes on the bottom. So I'm putting moles of hydrogen on the bottom. The unit that you're going to goes on the top. So in this case, moles of water. Notice the mole unit is staying the same, it's the identity that's changing. When you go side to side, these numbers that you use are your mole ratios, your coefficients from your chemical equation. And this is the only time that you use those coefficients in a calculation. So in front of the hydrogen, I had a 2, so I'm going to put a 2 in front of my hydrogen in my mole ratio. In front of my water, I had a 2, so I'm going to put a 2 in front of my water in my mole ratio. Now that puts me over here on my flow chart. But look, now I hit another arrow, which means I need to draw another X and another line. The unit that I'm going from goes on the bottom, so this is moles of water. The unit that I'm going to goes on the top. So in this case, this happens to be grams of water. Notice in this example how now, or in this step rather, how the water part of the unit is staying the same, but it's the unit that's changing. When we see grams and moles together, remember that a 1 always goes in front of the mole, and the gram part comes from the periodic table. So what we see is that on the periodic table you have 2 times the hydrogen, which is 1.01, and the 16 for oxygen. So that means our molar mass is 18.02 grams per 1 mole. So 18.02 goes in front of the grams. Going through and canceling off our units, notice moles of hydrogen and moles of hydrogen cancel out. Moles of water and moles of water cancel out. The only unit we're left with is grams of water, which is what the question is asking us for, so we're done. And we put an equal sign, and we can now put that in the calculator. So that works out to 90.1 grams of water. After you become more comfortable with the steps involved, it's possible to show all your work in one equation, just like I did there. If you find that too difficult, you can certainly stop between each step in the equation. I'm going to stop at this point, and we'll address the next particular set of questions after you've had a bit of practice with this.